in this capacitor. And that potential energy can be used to do work. It can be transformed into other forms of energy. Now we can illustrate that by hooking up a light to our system. So let's hook up a light bulb. So we often illustrate light bulbs with something that looks like a filament and a circle around it. So there's our light bulb. This is one end of the light bulb. This is the other end of the light bulb, which are wires or the terminals of the light bulb. So let's put this light bulb in our circuit so that we could wire it up to our capacitor at will. So I will add a wire. Here's our light bulb. And let's add a wire on this end. And there is our light bulb. Right now, because the circuit isn't complete, the capacitor will remain fully charged and the light bulb will remain unlit. There's nowhere for the positive charge to go and nowhere for the negative charge to go because everything, all the wires in the circuit are at equipotential at the moment. And since all the wires are equipotential, there is not going to be any flow of charge. Let's now connect the light to the capacitor. So we'll do that by establishing a wire between the two. Now, once we establish that, remember, the capacitor is a source of potential difference. By establishing a charge separation, we have an electric field. Charges will move from higher potential to lower potential. So what does that mean? Once we establish the light, we allow a conducting path for the charges to move in the circuit. The positive charge will start moving from their higher potential to lower potential because an electric field is established due to the plates of the capacitor. That electric field will cause those positive charges to start to leave the positive plate, and the negative charges, as a matter of fact, will also start to leave the negative plate. So I'll indicate that with this green arrow. So the positive plate will start to lose charge, the negative plate will start to lose charge, but guess what happens? Those charges go through the light. And as they go through the light to complete their journey, they will cause the light bulb to light up. So initially, there's a lot of positive and negative charge going through the light because there's a lot of positive and negative charge stored on our capacitor. But over time, as the positive plate loses positive charge, where does that positive charge end up? It eventually will end up distributed throughout the circuit, but I'm going to indicate it going all the way to the negative plate. Essentially, the circuit that charge separation will diminish. As more and more charges are allowed to move through the circuit freely, the positive will be attracted to the negative will be attracted to the positive. So what will happen is the negative plate will become less negative, and the positive plate will become less positive, and eventually an equilibrium of charge will occur. There'll be an equal number of positive and negative charges distributed everywhere throughout our circuit. And when that happens, no more charge will be accumulated on the plates of our capacitors. No more energy is stored in our capacitor because there's no more separation of charge. And our light bulb will stop lighting. It'll dim in time.